Hi, welcome to the WTAMU Virtual Math Lab. This video will step you through College Algebra Tutorial 19, Example 3. In this example, we want to solve the radical equation, the square root of 2y plus 3 minus the square root of y plus 1 equals 1. In step 1, we want to isolate one of the radicals. It looks like we have two radicals here, so we need to get one of them by itself. So let's go ahead and move the minus square root of y plus 1 to the other side by doing the inverse operation of adding the square root of y plus 1 to both sides. When we do this, we get the square root of 2y plus 3 minus the square root of y plus 1 plus the square root of y plus 1 equals 1 plus the square root of y plus 1. This will simplify to be the square root of 2y plus 3 equals 1 plus the square root of y plus 1. In step 2, we want to get rid of the radical sign. In this problem, we have a square root for our radical. The inverse of taking the square root of an expression is to square it. When we square the square root, we will end up with just the radicand, which is what was inside the square root. When we square both sides, we will have the square root of 2y plus 3 squared equals 1 plus the square root of y plus 1 quantity squared. When we square the square root on the left side, we end up with what was on the inside of that square root, which is 2y plus 3. Now we need to be careful. The right side is like a binomial squared, which in general simplifies to be a plus b quantity squared equals a squared plus 2ab plus b squared. It is real tempting to say that the right side will be 1 plus y plus 1, but let's expand that out. We can rewrite it as 1 plus the square root of y plus 1 times 1 plus the square root of y plus 1. When we multiply this out, we still have the 2y plus 3 on the left side equals 1 plus the square root of y plus 1 plus the square root of y plus 1 plus the square root of y plus 1 squared. This will simplify to be 2y plus 3 equals 1 plus 2 square root of y plus 1, and when we square that square root, we end up with y plus 1. This will simplify to be 2y plus 3 equals 2 square root of y plus 1 plus y plus 2. In step 3, if we still have a radical left, we need to repeat steps 1 and 2. On this problem, after all that, we still have a radical, so we need to isolate that radical. So we need to do the inverse operation and subtract y and subtract 2 from both sides. This will give us 2y plus 3 minus y minus 2 equals 2 square root of y plus 1 plus y plus 2 minus y minus 2. This will simplify to be y plus 1 equals 2 square root of y plus 1. Squaring both sides, we will get y plus 1 quantity squared equals 2 square root of y plus 1 squared. Again, we need to be careful that we square the left side as a binomial squared, which in general simplifies to be a plus b quantity squared equals a squared plus 2ab plus b squared. So the left side will be y squared plus 2y plus 1 equals, and on the right side we'll square the 2 to get 4 and square the square root to get y plus 1. In step 4, we want to solve the remaining equation. The equation that we ended up with is a quadratic equation. If you need a review on solving quadratics, feel free to go to College Algebra Tutorial 17. Let's get this quadratic in standard form, which is ax squared plus bx plus c equals 0. Looks like we need to distribute the 4 times the y plus 1, and when we do this, we get y squared plus 2y plus 1 equals 4y plus 4. It looks like we need to move the 4y and plus 4 by doing the inverse operations of subtracting 4y and 4 from both sides, which will give us y squared plus 2y plus 1 minus 4y minus 4 equals 4y plus 4 minus 4y minus 4. This will simplify to be the quadratic equation in standard form of y squared minus 2y minus 3 equals 0. Since this quadratic does factor, let's go ahead and solve by factoring. Factoring the trinomial on the left side, we get y minus 3 times y plus 1 equals 0. Since we have a product of factors set equal to 0, we can use the zero product principle and set each of these factors equal to 0. Setting the first factor equal to 0, we get y minus 3 equal to 0. And setting the second factor equal to 0, we get y plus 1 equals 0. In the first equation, we can do the inverse operation of adding 3 to both sides and get y minus 3 plus 3 equals 0 plus 3, which simplifies to be y equals 3. In the second equation, the inverse operation we can do is subtract 1 from both sides and get y plus 1 minus 1 equals 0 minus 1, which gives us y equals negative 1. Even though we found 2 values for y, we are not done yet. In step 5, we want to check for extraneous solutions. When solving radical equations, extra solutions may come up when you raise both sides to an even power. These extra solutions are called extraneous solutions. If a value is an extraneous solution, it is not a solution to the original problem. In radical equations, you check for extraneous solutions by plugging in the values you found back into the original problem. If the left side does not equal the right side, then you have an extraneous solution. If the two sides are equal, then you found your solution. Plugging in 3 for y into the equation square root of 2y plus 3 minus square root of y plus 1 equals 1, we get square root of 2 times 3 plus 3 minus the square root of 3 plus 1 equals 1. Simplifying the inside of the square roots, we end up with square root of 9 minus square root of 4 equals 1. This will simplify to be the square root of 9 is 3 minus square root of 4 is 2 equals 1, which gives us 1 equals 1. Since we got a true statement, this means that y equals 3 is a solution for this radical equation. We still need to check y equals negative 1. We can do this by plugging it into the same equation. So we will get square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 1 equals 1. Simplifying the inside of the square roots, we get the square root of 1 minus the square root of 0 equals 1. Simplifying this, we will get 1 minus 0 equals 1, or 1 equals 1. Hey, we got another true statement, which means y equals negative 1 is also a solution. So our final answer is y equals 3, or y equals the negative 1.